this video, we will discuss about check if n and its double exist. Given an array ARR of integers, check if there exist two indices I and j such that I is not equals to j, I and j lie within the range, and ARR of I is equals to 2 into ARR of j. So what they are saying is that we are given an integer array in the input. We need to find two numbers from this array such that their indices are different and one element is the double of another element, right? So basically, we need to find such an I and j index where ARR of I is equals to 2 into ARR of j, right? This is what we need to find. And if such a pair exists, then we need to return true, otherwise false, right? So now there are multiple ways of solving this problem. So the first approach is the brute force approach, right? So in the brute force approach, what you can do is that you can fix one element from the array and then compare it with rest of the elements according to this condition. So basically, first you can fix this 10 and then you can compare it with others, that if 10 into 2 is equals to any of these. So in this particular case, your condition won't be true. Then you will fix 2 and you will compare 2 into 2 with 10, 5 and 3. Again, condition won't be true. Then you will fix 5 and then you will compare 5 into 2 with 10, 2 and 3. And you will see for this our condition will become true. 5 into 2 will be equals to 10. So in that case, you can return a true, right? So basically, we are one by one fixing an element and comparing it with all the other elements. So what you will do is that you will run a for loop of I starting from 0 till n. And inside this, you will run another for loop of j starting from 0 till n. And inside this, you will check that if your I is not equals to j, because our I and j has to be different, right? A number itself cannot be the double of itself, right? So if I not equals to j and ARR of I into 2 is equals to ARR of j. If this condition is true in any case, then return true. Otherwise, at the end, we can return a false, right? So in this case, our indexes are 0, 1, 2 and 3. So when your I would be equals to 2, then you would start your j from 0 and 5 into 2 will be equals to 10 and a true will be returned from here, right? Here we can also use ARR of I equals to 2 into ARR of j, right? Because the order doesn't matter here. I can be greater than j or it can be smaller than j, right? So now here we are running a loop n times the loop of I, and here also we are running a loop n times, right? So what will be the time complexity of this particular code? Order of n square, and we are not using any extra space. So the space complexity will be order of 1. Right? Looking at the constraints of the problem, the brute force solution will get accepted. But let's look at a little more optimized code. So instead of going into n square, what we can do is that we can keep all these numbers in a set, right? What I'm saying is that I will take a set and inside that set, I will keep all of the numbers. 10, 2, 5, 3, right? And then you will take each element from the array and you will check whether its double is present in the set or not. So you will take this 10, you will check if its double is present in the set or not. So it is not present. You will take 2, its double is not present. You will take 5, its double will be present here. So you can return a true, right? But here you would be doing two passes in your array, right? First for inserting these numbers into the set and then for checking whether their double is present or not, right? Instead, what we can do is that we can iterate in this array just once, and while we are inserting the elements into the set, we can also check whether its double is present or not, right? So basically what we can do is that initially our set will be empty, right? We will iterate inside the array. We will take the number and we will check whether its double is present in the set or not, right? So for this, there won't be present anything in the set. So we will just insert 10 into the set, right? Then we will take this 2. Again, we will check whether the double of 2 is present in the set or not. So it is not present, 2 will be inserted. Then we'll take 5. We will check whether its double is present in the set or not. So yes, it is present. So here we can return our answer as true, right? But see, If let's suppose 5 was present at the 0th index and 10 was present at the second index, in that case what would happen? So we would take 5. In our set nothing is present, so we would insert 5. Then we would take 2, its double is not present, we would insert it into the set. Then we have 10, 10's double is not present in the set, we will push 10. Then we'll take 3, 3's double is not present in the set, so we will insert 3. And now in this case your answer will be false, but ideally it is not false. Why? Because the double of 5 is present here. And why did that happen? Because 5 was already inserted. 5's double is coming in the future and we do not know that what are the future elements, right? So what we can do is that in addition to checking whether that element's double is present in the set or not, we can also check that whether that element divided by 2 is present in the set or not. So basically, I can write this equation as ARR of I divided by 2 equals to ARR of J, right? Since our I and J can be anything, I can be greater than J or it can be smaller than J. So in addition to checking the double, we can also check whether it's 1 by 2 is also present in the set or not. And another thing is that this by 2 we can do only when the particular element that we are considering is an even number, right? Whenever we are checking for number by 2, we will also check that that number should be even number, right? So basically, in the set, you will check that if let us suppose the name of the set is scene. So in the scene, you will count whether, let's suppose the current number is num. So you will check whether 2 into num is present or not. Or what you will check that if the number modulo 2 is equals to 0, that is, it is an even number. And in the set, the count of num by 2 is 1. If any of these condition holds, then we will return a true, right? So this is what we are going to do. Here you would be running a for loop in the array just once, right? So let's quickly code this out. So first of all, let us create an unordered set and we will make it as an integer. Let's name it scene. Then we will run a for loop in the array. So for int num in the array. And then we need to check that if scene dot count num into 2, or if the number is an even number, and scene dot count num divided by 2, right? If any of these condition holds, then return a true and then insert this element into the set, right? And at the end, return a false. So let's quickly run this. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.